Okay. Let me make sure you can see. Okay, you should be able to see my iPad screen. Is that right? Okay. So what I'm going to do first is I'm going to do a allegation problem. Okay. How many mils of 50% dextrose solution and how many mils of, that's water, are needed to prepare 4.5 liters of okay, of a 1% solution. So I'm going to first identify the fact that it is a allegation problem. Okay, so I'm going to go ahead and highlight my first percentage, which is a hint. And then remember, we have water, which has a percentage. And then we need to get another percentage. So we have 3. So that right there tells me that it is an allegation problem. I have a high, I have a low, and I have a desired. So if you remember anything about allegations, we need to make our little tic-tac-toe. Okay. And the, sorry. And the top left is going to have what? It's going to have the high percent. So if you have a 50% and water, obviously 50 is going to be the high. And water, if you remember, it's 0. And then our desired is going to be a 1% solution. Okay. So you will do 50 minus 1, which is 49. And you will do, remember, you do 1 minus 0, because if you do 0 minus 1, you'll end up with -1. That's not how you get it. So 1 minus 0 is 1. Okay. So the next part of our allegation, we need to consider these are going to be parts of our total solution. So if you add up how many parts, that's 1 part and 49. So 1 plus 49 is 50. Okay. So that means that 1 over 50 parts of our 4.5 liter solution comes from our 50% dextrose. And 49 over 50 parts comes from our water, but it's still our 4.5 liter solution. So I'm going to go ahead and just keep it in liters just for posterity's sake. But you could go ahead and convert it to mils anyways, because the answer is wanting it in mils. So I can write that right here. So that's 4,500 mils, right? So we need to do 1 over 50 times 4,500. It's going to be 90 mils of 50%. Okay. And then we have 49 over 50 times 4,500. That is 4,410 mils of water. Okay. So are those answer choices? Yes, they are. And that is correct. So it's very important, number one, that you identify what you're doing. So obviously start with, okay, is this an allegation problem? Okay, well, do I have a high, a low, and am I trying to meet somewhere in the middle? That is the hint that is an allegation. Remember to do the, diagonal, you subtract. And then the last step that everyone always forgets is this right here. Make sure you understand where I got this, right? Because the 1 and 49 are parts of your 4.5 liters, okay? So I'll do one more alligation problem. I'll just scroll to a random one. Let's do the ointment one because that's a little different. So you have on hand 10% and 3% ointments. You need to prepare 450 grams of a 5%, so no, not solution, sorry. Ointment. How many grams of each of the 10% and the 3% ointment do you need? Okay, so remember, and you will most likely face a problem similar to this. Even though it's not a solution, we have to think about, okay, we have different concentrations of things. And when you have an ointment or a cream, this is a solid measurement. This is a, it's not a liquid, it's a solid. So you need 450 grams of 5%. You only have 10 and 3%. So you have concentration here, okay? So you have 10 and 3, you need to make 5. So we have 10 on our high, 5 on our low, and we have 3. I'm sorry, I wrote that wrong. You are desiring a 5 and you have a 3. Okay, so 10 minus 5 is 5, 5 minus 3 is 2. So now, if you remember what's next, you need to add those up. 2 plus 5 is 7. So it turns into 2/7 and then 5/7. Okay, well, how much are we needing to make? Well, it's right here. So 450 grams. So you will do that times 450 grams. So I'll do 2/7 times 450, and I will get 128.6 grams. 5/7 times 450, and I will get 321.4 grams. And that is the answer. Okay. So it's pretty much the same, right? You have 2 concentrations of different product. You need to make a concentration in the middle. 1, 2, and 3. That is a good hint that is an alligation problem. And I think for the most part, everyone is pretty good with those. So the next one I'm going to do, which is going to be one that you are going to face, is a pediatric dose problem. So we're going to do one of the multi-part problems. Okay, so it's going to take me a little to write it out. A patient weighs 28.6 kilos. And I'm not going to put their height because it's filler info. Acetaminophen is recommended for 10 to 15 mg per kg per day. The physician orders 325 mgs per day. Okay, so on these, you have to think of 4 things. The first thing you have to think of is, you got it, what is the min accepted dose? So I'll put min, but it is the minimum accepted dose. Okay, so we have to ask ourselves, how is this medication dosed? Well, it's based on the patient's weight. What is the patient's weight? It is 28.6 kilos. So we will take 28.6 kilograms, and the acetaminophen is dosed in either 10 or 15. So which one is the lowest one of those numbers? It's 10. So we will take 10 mg per kg per day, and we multiply. Because for each kilo they will get 10 milligrams, and they don't weigh just one, they weigh 28.6. So when you do that, kgs cancels, and you will get 286 mgs per day. Okay. Number 2. What is the max? Okay, just like we focus on 10 because it was the lowest number, we're going to focus on the highest, which is 15. So we're going to do it the same way. 28.6 kgs times 15 mg per kg per day. And we're going to do 28.6 times 15. You'll get 429 mgs per day. Okay. Now we have a min, and then we have a max. Okay. So right here is the lowest dose the patient can take. This is the maximum dose they can take. We've established that this is 286, and this is 429. That's per day. So let's ask ourselves, okay, what did the physician order? They ordered 325. So if you put it on a number line, 325 is somewhere right in the middle, right? So you ask yourself, is that appropriate? Yes, that is. So 3 is literally just yes. Okay. The last question. This is based off of knowledge of proportions. Okay. How many mil for one dose as the physician writes? So for those, you will assume that the physician has, clarified that they want it, and you will say 160 milligrams per 5 milliliters. Okay. So the physician wants how many milligrams? The physician wants 325 milligrams. We don't know how many milliliters we're going to provide to the patient, but we're going to calculate it. And then we know that our product comes in 160 milligrams for every 5 mils. So we will take 325 times 5 divided by 160. And you will get 10 point, we'll call that 16 mils. Okay, that is the answer. Okay, so I hope that those are pretty good. I hope that those are all right. All pediatric basing is on weight. So you need to, number one, convert to kilos always. You need to evaluate, okay, how many insert unit of drug per kilo do they need? And sometimes it'll say either milligrams per kilogram per day. It might even say milligrams per kilogram per 6 hours. Okay. So we will do a weight-based. Let's do this one. So we're going to do Number 5 on weight-based. Okay, so we have a couple problems. We have, if you read along, he requested aminophylline infusion. The order is for 1,000 milligrams of the drug in 500 mils of dextrose, 5%. The patient weighs 182 pounds and they need 0.6 mg per kg. You're asking for how many mils will deliver this dose. So remind yourself, the dose is for 1,000 milligrams, okay? So we know that the patient weighs 182 pounds, and if you ever see 182 pounds, I want you to go ahead and convert that into kilos. That is 82.73 kilos, okay? How many milligrams per kilo is he getting? 0.6. So for every kilo he gets, or I'm sorry, he weighs, you will get 0.6 mg per kg. Once again, when you multiply these, sorry, I marked that out. Kilos cancel. And that is going to be 49.6, let's call it 6.4 milligrams. Okay. So the order is for 1,000 milligrams in 500 mils. So we need to know, okay, if he only needs 49.6 milligrams, we need to know when to stop it, when he has achieved his total dose. So we have our 1,000 milligrams in 500 mils of dextrose. And on this side, we have what we now know as the dose he needs, 49.64. So you will do so you get 24.82 mil. And that is the correct answer. So just remember, even if the bag is way too much, that's okay, because due to the way dilutions happen, we can figure out, okay, when it needs to stop. We need to figure out when we need to pull the plug when he has achieved his dose that he needs. And that is the kind of the power of that ability. Okay, we will do this one because I remember this one being a tough one last night. It's going to be number 10. So I'm going to put IVIG, but just know that's immune globulin. It's available as 6 grams per 100 mils. Order for a 55 lb patient, 0.2 grams per kg IV. It says how many mils are needed for the dose. Okay, so first things first, you already see his patient weight, so you need to do 55 pounds divided by 2.2 equals 25 kilos. And how many grams is he getting for each kilo that he weighs? 0.2. Grams per kilo, kilos cancel, and we'll end up with grams. 25 times 0.2 is 5 grams. Okay, so we have a drug available in 6 grams per 100 mils. 6 grams, 100 mils, and we know he only needs 5 grams. So we'll do we will do 5 times 100 divided by 6. And we will get 83.33, which is the correct answer. Okay. Once again, you have a concentration of a drug, you have a patient weight, and you have their dose. Okay. That is all on weight-based. And now we're going to do the dreaded drip rate. Okay. So we're going to do number 7 on drip rate. So I'm going to write the problem first. I'm going to put KCl for potassium chloride. How many MEQ per hour? Okay, so we know we have 30 milliequivalents in 1 liter. We know we're pushing it out at 125 mils per hour. We need to know how many milliequivalents per hour. So what we'll do is we'll take our drug and we'll put it in our solution, which by the way is 1,000 mils. 1 liter is the same thing as 1,000 mils. And so if we do this calculation, it's going to tell me exactly how many milliequivalents are in 1 single milliliter. And that is 0.03 MEQs per mil. Okay, we know we're pushing it at 125 mils per hour. Okay, and if you know anything about multiplying with similar units, those will cancel. So you're going to end up with milliequivalents per hour. And that is your answer. Okay, we're going to do number 9. I'll zoom out just to show the problem. 30 MEQs, 1 liter, 125 mils an hour. Number 9. An order is for heparin IV 1,000 units per hour. We might have to do another meeting after this, by the way, because we only have 10 minutes left in this one. So stand by. Okay. Basically, we have a 500 ml bag with 25,000 units. So that's going to be my first step. I have 25,000 units in 500 milliliters. So if I do this operation, it's going to tell me exactly how many units are in 1 milliliter. That is 50 units per mil. Okay. We already know that it's set for 1,000 units per hour. So if it's 1,000 units per hour, and we know we have 50 units per mil, this operation will tell us how many mils that takes. 20, and that's mil per hour. And if you're sitting there saying, okay, how did you know to divide? Well, because you need to say, okay, well, if I need 1,000 units in an hour, I know that I can provide 50 units for every single mil. So you need to say, okay, well, how many of my 50 units per mil do I need to get to 1,000? So it's dividing, and you get 20 mils per hour. Is that the answer? It is the answer. That is it. So we're going to do one more, and then I'm going to start a new call, and then we're going to do the last homework for a little bit, and then I'll make some closing remarks about what to really look for the math. This is a good one. We're going to do number 12. All right. So we have 100 mics in 240 mils. So if I do this calculation, it'll tell me how many mics are in 1 mil. That's 0.417. We need 75 mics per hour. And so if we have 75 mics per hour, and I can provide 0.417 per mil, this cancels, so we get 179.86 mil per hour. And it says 1 mil is 15 drops. So I will just do that times 15. 15 drops per mil. So when you do 179.86 times 15, you will get 2,697.9, and then that is going to be mils cancel. It's going to be drops per hour. But it says, what is the drop rate in drops per minute? So you have to remember that there are 60 minutes in an hour. Hours cancel. So when you divide by 60, you'll end up with 44.965, which we're going to call 45 drops per minute. Okay. So once again, 100 mics, 240 mils, there. Okay. All right. So let me go ahead and get back to the class. No. Anyways, so we will stop this call and then we will finish with allegations. No, I think that's all. I think that covered everything. Right? Pediatric, weight-based, allegation, drip rate. I think that covered everything. So if no one has any questions, and if anyone has any questions, just throw them in the chat. But if no one has any questions, I think that's where we're going to stop. So please go through this. Maybe I'll go ahead and save this document and send it to the group, just so everyone can see my work and sort of how I work through this. But, you know, basically, the most important things are just remember your units when you're working. Also, let's cover some things real quick. Sorry. Remind yourself what NS means. NS is normal saline, and that is sodium chloride 0.9%. If I say LR, that's lactated ringers. If I say D5W, that's dextrose 5% in water. If I say SWFI, that's sterile water for injection. So if you see anything like D70W, that is dextrose 70% in water. And remember, when you see anything with a percent, so 70%, that literally translates to 70 grams in, you got it, 100 mils of whatever it's dissolved in. Okay, so do not let that escape you. You will be confronted with percentages. Very easy to remember. Don't forget that. Remember, microgram is 1 over 1 million of a gram. Milligrams is 1 over 1,000. So if you said you had 500 micrograms, that would be 0.5 milligrams, right? Because there's three zeros, so it's 1, 2, 3, and it's 0.5 milligrams. Don't forget that. Don't forget that, you know, if I weigh 200 pounds, I need to get that to kilos. You will divide by 2.2 every time, okay? Okay, and when it says milligram, so let's do 1 milligram per mil. I'm sorry, no. Let's do 5 milligrams per kilogram. That means every kilogram they weigh, they will get 5 milligrams.